Hello everyone, welcome to this session. In this session, I am going to explain the siphon with the animation. The siphon is the one of the hydraulic phenomenon which is used to make the flow of the fluid from the one container to the another container or in the open atmosphere. And for this, we are going to use the YouTube. And that YouTube is having the at the middle portion higher level than the higher container level. And how that works and with the explanation as well as I'm going to take the with the animation in this session. Here the siphon is a familiar hydraulic device. It is commonly used to cause a liquid flow from one container in an upward direction over an obstacle and then flow downward into a second lower container. A siphon consists of U-tube with a one end submerged below the surface of the liquid in the container. Then the center portion of the U-tube lies above the level of the liquid surface and the free end lies below it on the outside of the container. Okay, this is how the siphon is to be. Then we'll see here. You can see here this is a higher container and outside it is open, and this is a U-tube. U-tube is inserted in the liquid in the higher container, that is taken as the section 1 or point 1, and the another point where the discharge is to be taken place, that is the point 2 of the U-tube. And here initially if we keep this is empty U-tube in this way, there is no water flow or a liquid flow. And here initially this U-tube should be filled with a water, and after that filling up the water into this U-tube, okay, this the outside lower level is held firmly closed. Then it is inserted into a higher level container so that the its open end and the higher level container will be below the surface of the water. And after that we have to leave the that's closed end of this free end. Then due to that uh, contained water inside the tube, the flowing of the fluid will be taking place. Due that forms a suction pressure at the free end, and there is a formation of the water column in the U-tube, and that water column forms a suction at the free end that will makes the flow of the fluid container from container to the outside, even though the level of the U-tube at the middle is higher than the level of the water in the higher container. And here we are going to take the level as a elevation head Z1 and Z2 from the uh, reference line, and difference between these two will be h. This we are going to make the use the to find the velocity of the flow at the exit. And here how the working is taking place will take here there how the working it will be taking place. We can see U-tube if it is kept commonly, there is no flow, and if it is filled completely with the water, then one end is hold firmly and left in the glasses, then the fluid will be flowing from the one to other. When this end, this is also becomes a lower level, from the container to the second container also flowing will be taking place. Like this, all three will become say one level. This is a simple principle we can use for the understanding. And for the fluid to flow out of the free end, two conditions must be met. The first one, the elevation of the free end must be lower than the elevation of the liquid inside the container. That is the first condition. Second one, the fluid must be initially forced to flow up from the container into the center portion of the U-tube, and this is normally done by temporarily providing the suction pressure at the free end of the siphon. For example, when siphoning the gasoline from the automobile tank, a person can develop this suction pressure by momentarily on the free end, sucking on the free end of the hose. This allows the atmospheric pressure in the tank to push the gasoline up in the U2 hose as required. For continuous flow operation, the free end of the U-tube hose must be lie below the gasoline level in the tank. Usually, from the to remove the gasoline from the tank of the vehicle, we are going to use the pipe, and where the siphon is method used to remove the gasoline from the tank. And commonly, the persons who are working in the garage, they are going to use this method, but they are don't know that one what is this siphon, but they can use that one by their experience. Here, we can analyze the flow through the siphon by applying the energy equation using the points 1 and 2. Here we are going to apply the energy equation, that is Z1 potential energy, pressure energy, and kinetic energy. There is a pump head, motor head, and the level head. And this is Z2, that is a potential energy, and this pressure energy and kinetic energy at point 2. Then the conditions, the following conditions apply for the siphon. That is a pressure P1 equal to P2 atmospheric pressure. At suction inside the upper container as well as outside the upper container, both pressures are atmospheric pressure. The area of the surface of the liquid container is large. Then the velocity V1 is equal to 0. There is no pump or a motor, HP and HM equal to 0. Z1 minus Z2 equal to H. There is a differential head between the level, liquid level in the container and free end of the U2. Substituting these values, we can have that is Z1 only remains at the inlet. There is a potential energy, and HL will be there as due to the level, and this is Z2 at the potential energy at the point 2 and V2 square by 2, and inlet the velocity is also 0, V2 square by 2. By simplifying this equation, we are going to have the velocity at the exit. This velocity we are going to have, and 2g z1 minus z2 minus of HL from this equation we can simplify, and here we can take the under root of 2g h, this z1 minus z2 what is there, this can be taken as the h differential head and the HL, and these are the equations where the velocity we can get at the outlet by the analysis, but the operation also we should know it. Thanks for watching. If you like, share, subscribe and comment.